Alright, so this problem is on Chapter 7. It is about force and work on an angle. And the problem reads, you are loading a refrigerator weighing 2,443 newtons onto a truck using a wheel cart. And the refrigerator is raised 1.11 meters to the truck bed when it is rolled up a ramp. And you're to assume that the ramp and the refrigerator have no friction at all in between them. And part A is you have to calculate the minimum work that must be done by the force you apply and the magnitude of the force if the ramp is at an angle with a horizontal of 45 degrees. Okay, so first for work, you must know that work equals mass times gravity times height, or mgh. And what's given here is the weight, which is mass times gravity, which is 2,443 newtons. And we have the height as well, which is 1.11 meters. And all you have to do is multiply those together, and you end up getting 2,712 joules. Alright, and to find the force, well, that equals mass times gravity times sine of theta. Okay, so we already know theta and mass times gravity. So you just multiply 2,443 newtons times sine of 45. And if you know your trigonometry, sine of 45 is just 1 over square root of 2. So the exact answer of this is 2,443 over square root of 2 newtons. And the approximate answer for that is 1,727 newtons. Alright. And there's part B here, which is the exact same thing as part A, only theta has changed. Instead of 45 degrees, theta is now 11 degrees. And to find work for this, it actually is the exact same thing as the first part. It is 2,712 joules. The reason why is work is not dependent on the path. As long as it's the same height, it'll always be the same work. If you're going 1,000,000 miles to the left and then 1,000,000 miles to the right and going up in a crazy, 100 meters up, 100 meters down, as long as you end up, in this case, 1.11 meters in the y direction, you will have the same amount of work as if you just took the direct path. And this is assuming that everything is frictionless. It would be different if there is friction, or air resistance, etc., etc. Any real world situation. Anyways, so, but the force here would be different because theta has changed. So you just take 2,443 newtons times sine of 11 degrees, and that will get to you 466 newtons. And there we go. Great job.